Hi, my name is David Fullis, and I'm a member of the WebSphere Application Server for zOS development team in Poughkeepsie, New York. This is the second in a series of video lessons designed to introduce you to WebSphere Application Server. Here we will focus on WebSphere Application Server running on the zOS operating system. Now let's talk about System Management Facility, or SMF for short. SMF has been a part of the zOS operating system for a long time, and zOS itself has exploited SMF since the very early days of the product. In version 7, a brand new SMF record was designed and implemented for zOS. It's called the SMF120 subtype 9 record, or 120.9 for short. Picture a zOS application server in the SMF function of the zOS operating system. Now, picture requests coming in from users and responses going back. With the SMF120.9 record, information about every request is written out to SMF. SMF is a very efficient recording function. A great deal of the writing is first done to memory buffers and later rolled out to files. The impact to your system of using the SMF120.9 function has been shown to be very low. Each request record written includes information about the WAS server resource that was used to service the request, information about the arrival time of the request, when it was dispatched for execution, and when the request was completed. Right away you can see how this information might be very useful. This arrival and completion information may be used to validate response time for a system, which is useful in confirming that service level agreements have been met. That information is, of course, summarized by RMF, but the WAS SMF records provide specific results for each request processed. There's a wealth of information about the CPU time consumed for each request. That includes general processor time and ZAP and ZIP time as well. This provides you the ability to charge back based on actual usage by request. Networking information is captured, such as the hostname and port a request came in on and the number of bytes taken in and processed back. We stress again how this is a very low overhead facility of the zOS operating system. During testing of this function, we determined that the overhead of capturing the basic information degraded throughput by about 1%. Of course, your results may vary, so we do not wish to imply a guarantee of your performance. Your own testing will bear out the efficiency of this function. What the SMF120.9 record provides, actually what SMF in general provides, and what the SMF120.9 provides specific to zOS, is the ability to capture meaningful statistics about activity and usage. This information may then be used with analysis routines to perform capacity planning, to chart trends of application and system usage, to determine compliance with service level agreements, and to provide accurate accounting for chargeback of system costs. Let's now take a very brief tour of how the servers are started. What you'll see is that only the controller region is started by you. The rest is automatically started by WAS itself. A standard zOS start command is issued to start the controller. The format of this start command should be familiar to those who've worked on zOS before. It consists of the start procedure to use, the job name desired, and then a parameter called env equals that is used as a shortcut to a key initialization file for the server. The daemon, if not already started, will be started automatically. The first servant region will be automatically started. And any additional servant regions will be started as well, depending on how you configured the server. You may wonder why we showed that in this presentation. We had two reasons. First, we wanted to let those familiar with zOS know that zOS is operated in a way that conforms to typical zOS start and stop practices. Another reason was to show that even though zOS server consists of multiple address spaces, they're all logically organized around the controller region. You start the controller and the others are started automatically. The controller is what hosts the listener ports. Users connect to the controller. And in many ways, the controller becomes the app server. And in a sense, that takes us back to the WAS is WAS story we've been talking about. Yes, a zOS application server has a different execution model from that on other platforms. But if you focus on the controller and consider the other parts as handled by zOS itself, you see many similarities to the operation of a WAS app server on zOS and other platforms. And please never forget that to the applications, the same open standard interfaces are seen across all WAS platforms. At the application layer, WAS is WAS, no ifs, ands, or buts about it. We'll now show you a video capture of a zOS server being started. This will illustrate the points made on this chart. In a moment, we'll give you a video tour of an actual WAS-zOS network deployment cell in the IBM Washington Systems Center in Gaithersburg, Maryland. This cell is configured across two LPARs in a parallel sysplex, sysc and sysd. The deployment manager is called QCDMGR, and it has its own node called QCDMNode. There's an application server node on the sysc LPAR called QCNodeC. It's a managed node and therefore has a node agent. There's a daemon for the sysc LPAR. This is called QCDEMN. Over on sysd, we have another application server node. This one is called QCNodeD. Because this part of the cell is on a different LPAR, it has its own daemon. Daemons are considered a cell-level thing, so there's no LPAR identifier in the name. This daemon is called QCDEMN as well. And for good measure, we have a server cluster that spans both sysc and sysd. It consists of two servers. From the administrative console point of view, this is what this environment looks like. And on that administrative console screen, there is nothing that indicates this is a WAS-zOS cell. We bring that to your attention because it's important to understand that WAS administrative skills learned on other platforms easily transfer to WAS on zOS. The administrative console is nearly identical across platforms. You don't see the differences until you go deeper into the configuration and get closer to the operating system. That's where you'll see things like JCL start procedure names and the split JVM model. But in general, WAS is WAS, and that holds for the administrative console as well. Let's begin our video tour of the actual WAS-zOS cell we just reviewed.